In this video we're going to look at limits and specifically problems where x approaches infinity. So if we take a look at this problem on the screen, if we plug in infinity into this equation, we get infinity on the top because we have x there and x there, so we have infinity squared plus infinity gives that infinity on the numerator, and in the denominator we have infinity squared plus 17, so that gives infinity in the denominator. So we have infinity over infinity, which is undefined. So we need to do a little bit more work to this problem. So a common thing we can do with these types of problems is divide the top and bottom of the fraction by the highest power term. So here we can see we have the highest power is that 2 there. So if we divide the top line by x squared and the bottom line by x squared, this can normally let us solve the problem. So let's do that. So So 5x squared divided by x squared will give us 5. 3x divided by 5x squared, the x on the top will cancel and we'll have an x on the bottom, and then we have 7 divided by x squared. What we do to the top line we need to do to the bottom line. So x squared divided by x squared will give us 1, and 17 divided by x squared. So by doing this step here, this normally allows us to solve the limit. So now let's try putting infinity in wherever x is. So we have x here on the bottom line, so 3 divided by infinity, that will give us 0. 7 divided by infinity squared, that will give us 0, because we have a very large number in the denominator of a fraction. We have a 1 there. 17 divided by infinity squared, that will give us 0 again too. So this limit is now equal to 5 over 1. That is the only two numbers left. So 5 over 1, which is of course 5. So the limit of this function here as x approaches infinity is equal to 5.